to grow their applications and be able to fulfill their goals, like solving technical needs that people have to get real world data into their system, right? And basically my presentation will be about why does DeFi rely on price feed, on kind of real world data in order to strive, in order to survive? Why is it a full part of the whole DeFi ecosystem that you really need to figure out if you want to grow this DeFi, this new kind of financial ecosystem on top of blockchains? So first, I'll go over the basics. What is the smart contract Oracle problem? Basically, if we go really at the beginning and the kind of basis, what are smart contracts? Smart contracts are agreements which are enforced by codes where a party can enter into another party without having to trust a third party. Like I don't need to trust a bank in order to enter into a financial agreement with someone else. I can basically trust a smart contract, which was coded, which basically is open source, which is deployed on the blockchain, and which will enforce basically the agreements that I entered into, right? Now, the main thing with agreements is that they're mostly data-driven. Basically, if we take into account, for instance, or take, for example, the payment of a certain amount based on the delivery of an asset, right? Like, let's say we're delivering a bunch of TVs or a bunch of a kind of sets of objects, right, to a user or to someone. And whenever this delivery is made, there is a payment that needs to be triggered. Well, smart contracts don't have access to this kind of data. They cannot track the delivery of something, of an asset, right? They need to have a way to get info, to get kind of this information on the blockchain. So that's why oracles come into play. Basically, oracles allow to get real-world data into blockchains, and they need to do this in a secure manner, right? Because whenever you leverage smart contracts, you have to keep in mind that all the properties that make smart contracts so great, like determinism, basically whenever you get a certain input, you get always the same kind of outputs. So if I get my delivery delivered on time, I get my payments processed, right? Well, if this data point coming from an oracle is actually wrong or has been manipulated by kind of a corrupted oracle or malicious oracle, then it means the payment would still happen because the input would be a false input, which would probably trigger a payment whatever happens. And there, unlike the kind of real world, you have no recourse, right? When something is made in the blockchain world, this never goes away. Like it's basically something that can be reversed. That's one of the properties of blockchains, immutability. So basically, oracles are a huge component of kind of the blockchain world and this whole ecosystem we're all trying to build with DeFi and with many other applications, because oracles require real-world data. And without this real-world data, you cannot build anything. Basically, we'll go into it, but real-world data is what? It's markets data. It's basically getting the price of assets like gold, like silver, and being able to create synthetic assets out of these. Like, for instance, I want to create a synthetic asset which tracks the price of gold and allows me to get exposure to this asset. Maybe I want to track the price of Amazon shares or kind of stocks and stuff, right? I'm able to use a price feed, which allows me to know the price of it. And then I can mint a synthetic asset, which gives me exposure to a certain asset, right? Then you have events data. So that's typically what I was talking about. It's executing a payment based on delivery. It's, for instance, ensuring a car based on the mileage of this car, right? So, for instance, the new Tesla cars have sensors built into the Tesla, which allow you to know how much was kind of driven by the car, what the temperature is, like a lot of information that you can use into insurance. And the way to get this info into a blockchain, a smart contract, would basically be to use oracles. And then, of course, you have the other way. Like you have, like here I was talking about the inputs, you also have the outputs. The outputs are, for instance, I'm going to trigger a PayPal payment based on the delivery of an asset, of a car, let's say. And I'm going to trigger it based on a smart contract interaction with an oracle. So an oracle is going to ping my contract when a car has been delivered, and I'm going to trigger a payment on PayPal using another oracle, which this time is not going to feed an input, it's going to execute an output, the output being execute a payment using this traditional payment system. And that's actually going to come in very handy because a lot of people today can't really get into the crypto world, but not the crypto asset world, but the smart contract world. Like the smart contract world has so many properties which make them so kind of attractive to enterprises, right? Like not having the overhead of manually managing contracts, of manually settling contracts, having to pay a third party. All of these are extremely attractive proposals, but people are kind of blocked in a way because they can't really access crypto payments, right? They don't want to transact in Bitcoin or even in stable coins. So being able to trigger payments on PayPal and Visa using a smart contract which is being fed info by an oracle is actually a huge value prop. So I kind of want to go over what do we have today, right? Like, I'm talking about a lot of use cases which require data, but today, and actually it's been getting much better, but what we are seeing in the past few months, even like maybe 5-6 months ago, was 90% of the use cases were based on tokenization of assets. It was basically you tokenize an asset, you own this asset, and you're able to transact with other people. It was ledger management, basically. I'm able to manage a ledger, I'm able to transact this asset between one person and another, but like that's not really the core of what DeFi and of what thriving ecosystem should be. A thriving ecosystem, which actually tends to replace what we have today, the traditional world, should be able to interact with data because most contracts are data driven. Actually, almost every contract is data driven. You need to be able to go from what you have today, where only a few contracts are triggered by real world data, to what we want to get to, which is this diagram on the right, is basically what do we have once we get the DeFi ecosystem and gaming ecosystem and an insurance ecosystem thriving fully. Well, a lot of these ecosystems will be triggered based on data inputs. And basically we'll go from the tokenization, kind of majority tokenization use cases we have today, to these kind of ecosystems which rely mostly on data, on real world data, triggering smart contracts, being able to trigger interactions and being able to trigger actions in a smart contract based on real world data inputs. So I'm able to trigger the liquidation of an asset that of a position in collateral that a user puts because the price of this asset reached this amount. I'm able to trigger the payment of this contract because this asset was delivered. I'm able to do this, I'm able to do that because you have real world data and you're able to access the most key data there is, which is in the real world, because blockchains don't natively support, of course, being able to know what the price of gold is right now. You need oracles to do it. So a quick kind of walkthrough of what the industry has been kind of going through these last few years. And I mean, the first kind of programmable thing we had on blockchain was multi-sigs, right? If I have n of k of n signers, then I'm able to transact, to do these transactions, right? Like if I have k of n signatures, then this transaction will go through. That was multi-sig. It was kind of first programmable contract on Bitcoin, even though it's not a contract, it's a script. But yeah. Then we went to protocol smart contracts. So protocol smart contracts were basically when people had to, when developers wanted to build something, had to kind of build it at the protocol level. So let's say you want a synthetic asset platform, or let's say you want a money market platform, you had to build it at the base layer, basically. So if you want to implement DeFi onto Ethereum, you would have to kind of build the logic as a layer one, right? That was extremely that was impossible to achieve, because basically what it would mean is you have to constantly change the way your smart contract logic is processed. And it was just not smart contract, but the way your layer one works. And basically that was extremely risky. That was taking a lot of time. That would have never kind of scaled, right? So what we saw is Ethereum, and where Ethereum really succeeded in changing the industry is it allowed anyone in the world to create a smart contract very easily, very quickly, in maybe 20, 30 minutes if it's a smart contract which is audited and which which like using a template, basically, you could deploy it very, very quickly without much overhead, right? So it's basically a 10x experience where in the Bitcoin days, you had to create kind of contracts which were based on the layer one of the protocol. And now with Ethereum, you are able to deploy smart contracts much more easily, right? And even though you still need auditing and you still need all of this very important stuff in order to launch something into production, you are still able to create new applications in a much quicker way, right? So we went to this phase, and this phase was basically the tokenization phase, which we saw mostly represented in 2017, right? When people really discovered the value of this. I can issue a token and I can sell my token and I can raise funds. That was the biggest use case at the time. To where we are going to go, in my opinion, and where we are going to go is basically contracts which are externally connected to the real world. What it means is these contracts are being triggered by real world events. So you can call them externally connected smart contracts. You can call them kind of real world event based contracts. Like you have many kind of wordings for that, but what it basically means is I'm able to replicate everything I have in the real world in the blockchain world. What cryptable smart contracts was, it was a good way to issue ownership of an asset. It didn't cover 10% of what we see of the kind of value interactions we see in the real world. However, what we see here with externally connected smart contracts, it basically covers anything you have in the real world: financial applications, insurance, global trade. All of this stuff is accessible once you get access to real world data. And that's really the exciting part. It's basically unlocking the whole value which blockchain was meant to unlock. And you needed oracles to do it, basically, and that's what we've been working on. So yeah, I'll just go into how basically an ecosystem can evolve once you get access to this real world data, right? So that's the growth of DeFi. So basically, DeFi has been rising a lot in the last few months. It's actually not updated to the latest trend. The latest trend is actually $4 billion locked in DeFi, I think. And basically, whenever you look at the DeFi contract, you have to see the two parts, right? You have the off-chain part, which is how do I get the data I need to get in order to mint an asset, in order to allow my users to borrow against a certain asset, in order to trigger liquidations. If a position is under collateralized, how do I get this data? And that's the off-chain part. That's basically the whole Oracle part we'll deal with, right? And the way we deal with it, I'll go into a bit later, but you basically have a network of nodes. And these nodes, you can think of them just like you would think of Bitcoin or Ethereum miners, but except that they're not mining states. They're actually mining data. They're each accessing an endpoint, like an endpoint for a data point, right? And they send this data on the blockchain. And basically, they're mining this data constantly, and the data needs to be stipulated by the smart contract creator. So I'm a smart contract creator on Ethereum, on Bitcoin, on Flow. Actually, not Bitcoin yet, but on Flow, on Ethereum, on Polkadot, on any of these blockchains. And I say, all right, that's basically the data I would like to have on my contract. I'm going to trigger an interaction with this specific set of oracles, and these oracles are going to fetch data from this specific set of endpoints. So they're going to be mining data for me at this frequency I specified. And basically, the node operators will be mining the data and getting rewarded in link tokens every time they mine the data. And here, basically, the link tokens will be paid by the smart contract creator. It allows you to align incentives, right? Where basically node operators get paid in link. In return, they pay data providers a subscription, or they subscribe to their service. And the smart contract creator is able to have all of this data, which he needs to function, flowing to his system, right? That's the kind of a premise of it. If we go to what we call end-to-end reliability, it's basically that any input fed into a blockchain system needs to have the same kind of security guarantees as this blockchain itself has. So what this means is if Ethereum Classic, if Flow are securing a few hundred millions, a few $1 billion of assets, then I need the security of whatever is going to go through and go into my blockchain to be as to have the same kind of guarantees, right? And the first guarantee of security in the blockchain and kind of distributed world is decentralization. So it's getting as many node operators as possible, or miners, in the case of blockchains, to get the same, to mine the same kind of data point, right? And instead of coming to consensus on the state of the blockchain, node operators will come to consensus on the state of a data point. So a good way to represent this and to kind of understand how it works is our price feeds. So our price feeds are basically data points, like the price of, let's say, ETH/USD. And these data points are being fed by multiple different actors, so like node operators, right? So in this particular diagram, I'm showing you 21 different node operators. And these node operators, as I was saying, are constantly mining data. They're constantly pinging an API and sending the data from this API to the smart contract. The smart contract then takes all of this data. It takes the median, and then the median is considered as a kind of source of truth for the DeFi applications which need this data. So here what you see is that we have 21 different nodes coming to consensus on the data points. They're each fetching data from a different data provider. That's also important. Like if you had 21 nodes fetching data from the same provider, it would actually be a pretty big risk, because it would mean that if the provider was to fail, then potentially the few $100 million of value securing kind of relying on this price would be corrupted, right? Simple example, a lot of people rely on our ETH/USD pair in order to determine when liquidation should happen on a platform like Aave and other kind of other applications. Well, if we were to feed, like if node operators were to feed the wrong data points, then liquidations would be triggered for no reason, and people would lose a lot of money, right? So you need to be very aware whenever it deals with security. You need security, and you kind of need as many node operators as possible, and they should be also using as many data providers who are as reliable as possible. And also, there is a very important concept, which is scalable security. What this means is if I have 21 nodes and I'm securing, let's say, $10 million of value today. If tomorrow I start securing with 21 nodes, $5 billion of value, then probably I should start scaling my security, right? And that's one other property, which is, in my opinion, great with this kind of concept, is scalable security allows you to scale how many node operators and how many data providers you have on your price feed as you wish. So unlike Ethereum or Bitcoin, where miners are going to, well, whenever you're going to send a transaction or to create to kind of input into storage, you're going to have to rely on the whole security of the network, right? You won't be able to kind of select a subset of miners. Well, with data and with Chainlink, you're able to kind of rely on just a subset of node operators. And what this allows you to do is to scale up the security of your operation and your price feeds as you're scaling up the value you secure, right? So the more node operators you have, the higher price you need to pay in Link token, obviously, because all of these people are being paid. However, you're still able to scale as you would require, right? Like you probably don't want to have the same number of node operators you had when you were securing $10 million than when you were securing $1 billion, right? So that's another concept. And basically the price feed I'm showing you here and the 30 other price feeds we have for multiple different assets are being secured by provable nodes, like basically people who you can prove their identity, you can prove that they're not being run by the same entity behind them, right? And multiple of these nodes are running with multiple data providers to ensure as much decentralization and security as possible. So that's the price feeds we have today. The price feeds, like just the one I'm showing you here, are actually being used by multiple different applications on Ethereum. So for instance, synthetic assets, so MCDEX, future swap, opium exchange, synthetics, all of these applications require to get a price whenever they're going to mint an asset, right? So a synthetic asset by definition is an asset which can track the value given out by a price feed. So I'm going to deposit some collateral, and this collateral is going to allow me to mint an asset, and this asset is going to follow the price of this given price feed, right? So synthetic assets rely on price feeds for liquidations, to determine strike price for options, for the funding rates in perpetual contracts. So really, like price feeds are an existential part of their systems to allow for synthetic assets, right? And keep in mind that derivatives and synthetic assets in the real world do make up a few, maybe 20, 50 trillion dollars. It's a huge fork, but I'm just telling you, like, it's a huge amount of transactions being processed in the real world are based on synthetic assets and derivatives, right? It's so whenever we want to recreate this system and kind of this traditional financial world on the blockchain, we need to get a way to do it, right? And in order to do it, you need price feeds because, again, blockchains don't have access to this data. But you need oracles, and the oracles create the price feeds. So lending and borrowing, then you have AV, you have BZX, you have DMM. So the way a lending and borrowing kind of platform works is I deposit an amount of collateral. Based on this amount of collateral, the protocol is going to look up the price of my collateral and the price of the asset I want to borrow, right? So it's going to kind of calculate the collateral to debt ratio and try to give you a percentage or an amount that you can borrow based on the prices at this given time. So if I'm borrowing some Ether, I'm able to, sorry, if I'm depositing some Ether into a collateral position, I'm able to borrow a certain amount of, let's say, USDC based on the price of Ether at this time, right? And that's based on the collateralization ratio, which is usually around 75%. I mean, over collateralization is 150%, sorry, on most platforms. So then asset management, it's basically how can I automate the way I'm kind of allocating my funds and kind of my money, right? So you have a lot of people in crypto who don't have the financial background, who have never traded in their lives. And what you're seeing is that people will be able to use stuff like set protocol in order to automate how trades are being conducted. And set protocol does need the price of Ether, of BTC, of DAI, and maybe sometimes even technical indicators in order to rebalance the assets of the users who are using the protocol, right? And then you have open law, which allows to kind of invest in multiple different projects with their law, and they're using our oracles to kind of determine the price in USD of the Ether amount that people invest. We have Nexus Mutual, which has a mutual fund, and they're pricing all of their assets on denominated in USD using our oracle. So basically, they're using the oracle to do the conversion between, let's say, DAI ETH and this kind of stuff. And then you have automated market makers, and one of the most important thing I would say I've seen there is Bancor, which with their new release is actually redesigning the way automated market makers work, right? So you probably know of AMMs. It's like, you probably heard of Uniswap, of Balancer, of Kyber. Well, what Bancor actually allows to do is they're going to rebalance a pool of assets. So basically what an AMM is at its very core, you have a pool of assets, you have assets X, you have asset Y, and the kind of multiplication, like the product should be X times Y equals K, K being a constant, right? Well, what Bancor is doing right now is that they're able to rebalance, and usually the proportion of each asset is 50%. So I have 50% ETH and 50% DAI, for instance, right? Well, instead of kind of having a fixed balance of assets, what Bancor allows to do is by checking the price that oracles are giving for, let's say, Ether or for DAI, they're able to rebalance automatically the pool. So instead of being 50%, 50%, if the prices are going to change, instead it might be rebalanced to 65%, 35% based on the price fluctuations. So it allows kind of liquidity providers to avoid losing money on arbitrage, right? Where arbitrageurs will usually kind of arbitrage between, let's say, an AMM pool and the centralized exchange. And then they'll be able to drive the AMM price towards the current price on a centralized exchange, right? While with what Bancor is doing by leveraging oracles, they're able to create a way to make it much more efficient to put money into a pool and to kind of keep your exposure to an asset. So for instance, before, people had to put, if I'm extremely enthusiastic on Ether and I want to only keep Ether, but if I still want to provide liquidity in order to kind of get fees from these protocols, I would have had to sell half my Ether and put it into DAI if it's an ETH DAI pool, and that then put my assets into the pool. Basically, I had to kind of have 50-50 allocation, right? So I would have to sell my prime position if I really believed in it. Well, now with what Bancor is doing, and thanks to using oracles, they're actually able to let users keep 100% exposure to the assets they want to own. So if I'm putting money into a pool which is 50% ETH and 50% DAI, I can still keep all my ETH and put 100% of my ETH into this pool. And what will happen is that the pool will automatically rebalance based on the amount that I put, right? And that's due to them being able to read the price of the assets at the moment of providing liquidity. So yeah, that's an extremely, I think, interesting development, because AMMs traditionally have had some inefficiencies. And I think it's really great to see how Bancor is solving them by using price oracles. So just something I wanted to highlight there. Something else to end my kind of presentation. So everything I showed you here was basically on Ethereum, right? Now, something to keep in mind is that Chainlink is a blockchain agnostic protocol, which means we obviously care a lot about Ethereum and about any blockchain we work with, but we also think that it's too early to tell if a blockchain will win it all or if it will be an ecosystem of blockchains. No one knows. No one knew that DeFi would be where it is at today. It's impossible to know in this space. So Chainlink does actually have this vision of providing data to any blockchain out there. And we have an extremely kind of agnostic way where the protocol was built in a way where you have an off-chain part, which is basically the Chainlink node. And the Chainlink node can actually be made to communicate with any blockchain or blockchain environment. They have two components. One is called the initiator, and the initiator basically monitors blockchain, and the adapter. The adapter basically writes to the blockchain. So whenever you're able to kind of customize this initiator and this adapter to the blockchain you want to communicate with, then you're able to have a Chainlink node which could fully interact, for instance, with Flow if it needed to, by running an initiator and an adapter which are compatible to a communication with Flow. And then we have the on-chain part, and the on-chain part is basically very simply the consumer contract, which is sending requests to a node operator, the Oracle contract, which is a contract that the node operator deploys on-chain. And this contract allows him to pick up new requests and to kind of get paid, right, in linked tokens. And then you have the linked token contract, which is basically the kind of so the token is the kind of blood of the ecosystem, where basically it's always circulating between node operators and the smart contract creators who are paying these node operators. And all of this, right? It's basically the economy of the ecosystem and the kind of rock that you need in order to build something like this. So that's yeah, and then I put a demo of an integration we have, for instance, with Polkadot. We have another with Near. We have another with Tezos. Like fully working integrations which allow people to communicate with other blockchains using Chainlink nodes. And I hope we can very soon get one for Flow as well. And yeah, we're still hiring people. We have a huge mission, which is to kind of, just like Ethereum and Bitcoin, act as layer ones and allow people to not have to build an entire blockchain whenever they need to create a new dApp. Well, our mission is to make it so that developers and brilliant people are able to not have to rebuild an entire Oracle network whenever they need to access data. And our mission will basically be fulfilled once we can see people who are able to access 10, 20 different data points in taking maybe 10 lines of codes by using Chainlink nodes and the Chainlink network underlying it with maximum security, actually the same amount of security that you would get using something like Ethereum on the layer one. So yeah, that's basically my presentation, and very keen to answer any questions you guys may have. Thank you.
Great, thank you so much for that presentation. That was very informative and fantastic information in there. So we have quite a few questions coming through. So I'll just get started at the top and we can work our way through them. So the first question is, we have seen many DeFi hacks via DEX price feed manipulation. How could Chainlink solve that in a decentralized way? What level of audibility and anti-manipulation does it offer?
Great question. So there is actually a point which is very often overlooked by people, which is data quality. So basically, whenever you're using a DEX, you're going to leverage maybe 10% of the volume of an asset. Like usually DEXs don't have that much volume for most assets, right? And it really depends. I mean, some ERC20s are very heavily traded on DEXs, but the wider market includes centralized exchanges and DEXs. And the combination of the two gives you the price you need in order to kind of securely price your assets, right? So what happens when you're relying on a DEX is that you're relying on a subset which can easily be manipulated because you're relying on something which doesn't have that much volume on it, right? So Chainlink nodes, what they do is that they use data aggregators, and the data aggregators are actually sourcing data both from centralized exchanges and decentralized exchanges. And this gives you the wide market discovery that you need in order to make sure that you're not going to be vulnerable to manipulation via flash loan and all of this stuff, right? So that's actually a data quality problem, which is solved by using, I mean, the price feeds, for instance, don't have this problem because they're using data aggregators, and because data aggregators know how to kind of how to create an index which allows to track the price of an asset, right? Like creating indices is extremely complicated, and in the real world, it's true that you would never see someone relying on one single source of like an exchange, because then it can go wrong. And that's what we saw with relying on DEXs. It's extremely risky, and the good thing is that no one is doing it anymore, or at least many less people, because there was a lot of awareness brought in the recent few months. Yeah.
Great. Next question is, microinsurance could be a great usage leveraging real world data plus on-chain triggers. But how could you make sure sensors are reporting real data? Any methodology you have seen to solve that?
Yeah, that's a great question. So in my opinion, the only way to create something there which will work is to have multiple sensors. Just like you're having multiple data providers to provide prices, and just like you have multiple node operators to kind of be the bridge between this data and the blockchain, you need as many sensors as possible, and you need them from a reliable data source. If you're using only one sensor, which is, let's say, bad quality and which doesn't have proper security guarantees, then to be fully honest, it's a almost impossible problem to solve, right? Because the data source at its core is corrupted. Chainlink focuses on providing data to the blockchain, but if the data in the first place is corrupted, then it's very hard to build a system around it, right? So if you're going to build a system around such, around low quality sensors, because for some reason you can only get low quality sensors and they might be kind of vulnerable to manipulation, then you should keep in mind that it's a very risky kind of system and you shouldn't put high value onto it. Yeah.
Right. Next question is, I want to leverage a more scalable chain-like flow for lower transaction costs, but would like to build a derivative DEX based on DeFi products on Ethereum via price feeds. The plan is to not need to transfer assets over via bridge, but the goal is to settle trades in stablecoins. Could I use Chainlink for that?
Yeah, absolutely. I mean, if I understand correctly, the main question is, I want to use Flow because it's scalable, but I want to use Chainlink price feeds because it's the only way to get data. And the issue is that Chainlink price feeds are on Ethereum right now, while we're actually really looking forward to actually supporting Flow and having price feeds on Flow. And once it's done, you won't have to have another component which is outside of Flow. You'll be able to have your price feeds on Flow and leverage this data and have your applications fully built on the blockchain of your choice. So as I said, Chainlink is agnostic, and we want to support all of the new blockchains which will have developers building on them.
Okay, thanks for sharing that. Next question is, based on what was presented, if I wanted a S&P 500 stock price feed to be built on chain options trading on Flow, could Chainlink handle that?
Yes, absolutely. So it would actually be quite simple. It would be very similar than Ethereum, right? We would have the nodes be able to communicate with the Flow blockchain. So they would have an external initiator, an external adapter. We would work to translate the contracts we have on Ethereum to supporting the native language on the Flow. And then we would have the same node operators that are currently providing data to Ethereum, provide data for let's say S&P 500. Now, keep in mind, S&P 500 is a more complicated data source to get than, let's say, crypto prices. That would be the only difference. We would actually, node operators would struggle a bit more to get this data. But on the technical side, it's totally possible. Anything that has an endpoint can have a feed on-chain. And yeah, long story short, we could do it and we would go the same way that we do it with Ethereum.
Okay. Next question is, how do you ensure a node operator is pulling data from a reliable source?
Yes, definitely. So actually, the good thing here is that, first, what we're seeing in the industry is that more and more sources are signing their data. So we're thinking of at some point kind of leveraging this where the provider of, let's say, data, I think one of the data provider actually, CryptoCompare, already signs their data. So by signing their data, you would have the node operators who are able to relay the signature on chain, and anyone can check that the data actually came from CryptoCompare, right? So data signing is one of them. The other one is, which we're working on, is SGX, where basically the node operator, once he's running a reliable source, cannot change this source, right? And you can have an attestation that he's running the source you need him to run. Currently, what we're mostly doing, and as you saw, the price feeds we have are actually not being run, like we don't have any node ourselves, like Chainlink, running the price feeds. It's all third-party node operators, right? And currently, these third-party node operators have an established reputation. They've been securing a few $100 million on the of assets on the staking networks like Cosmos, like Tezos, probably on Flow at some point. And basically, these people did kind of take on the subscriptions they needed to get reliable data, like the API subscriptions, and we're able to kind of corroborate on-chain that the data which is being sent by them is the data they're supposed to send, because all of their answers are written on-chain. Yeah.
Great. Next question is, how do you add new types of data feeds?
Yeah, definitely. I mean, currently, just to be clear, anyone could add a data feed. Anyone can add a price feed. Anyone can create their own adapter and access any kind of endpoints they want, right? So I'm going to run you through the process. What you need for a data feed is a contract, which is deployed on the blockchain you choose to deploy on. you need node operators who are going to be running the data you need, right? So you need to coordinate with node operators. For this, we actually have, I'll just share my screen very quickly. So we have listing services which allow you to coordinate with node operators. So that's a listing service where basically it was built by a third party, and you can see node operators, right? And you can see basically chain layer is providing data for these kind of different data points, so ETHUSD, DAI, and you can see basically what kind of adapters they support. So they support an adapter from Kaiko, right? So that means if I go to Kaiko, Kaiko is a data provider, and I can access any kind of price market data from them, right? So what you can do is you can coordinate with all of these nodes. You can tell them, all right, I need you to run this particular task. I'm going to pay you this amount for it, and you're going to be providing me this data, at this rate, right? And basically, you're able to set up your own contract and have your own node operators and coordinate with them fully using listing services. Keep in mind, we're actually going to have a new process going forward where people are able to have SLAs fully on-chain. So service level agreement, which would basically be an on-chain commitment from a node operator to honor a data delivery process, and they would back this commitment by staking an amount of link tokens, right? So currently it's a bit more manual, but yeah, we're going to this more automated way. And yeah, so that's a long answer, basically.
That's great. Thank you. Next question comes from Peter. Would you please be able to comment on Chainlink security in regard to Intel SGX vulnerabilities and cyber attacks?
Yeah, sure. I mean, look, very simply, we are big adepts of defensive depth approach, which is you add multiple layers of security on top, right? So you add decentralizations, and you add TEs with SGX, and you add other components which are maybe staking, which are reputation, all of this great stuff, right? So TEs and SGX are just a layer of defense. Now, the way I see it, no one is going to be, just to be clear, currently Chainlink nodes aren't running SGX. When they will be running it, no one will be forced to choose a Chainlink node with SGX, right? People will have the choice to either run a node, like use a node with SGX or use one without. The idea is that it's basically a completely free market kind of thing, where people who trust SGX and who want it because of its security properties can use it by getting node operators to get them data using SGX, right? But other nodes who don't trust SGX, like other smart contract creators who don't want SGX, who just want decentralization, who just want staking, won't have to use it, right? So to me, it's another choice, another added security. It doesn't corrupt in any way security. It actually enhances it by giving out more options, more choice for people.
Okay, great. Next question is, what real event use cases have you seen in addition to DeFi sector so far? Which are new ones you predict would grow in the future?
Yeah, sure. I mean, we've actually seen a fair bit of insurance use cases. So for instance, getting weather data with a user who we're going to announce very soon. They need weather data to have insurances. We've seen flight data at the time. Unfortunately, we won't be seeing too much flight data right now, but we had seen it for flight insurance. We've seen, let's say, we've seen many other kind of use cases revolving around unique data interactions, right? So this event happened. So for instance, we're even working on some cargo APIs, like cargo delivery APIs for other use cases around insurance. So I do think that anything regarding, I mean, to me, insurance is actually part of DeFi, right? It's decentralized finance in a way where, I mean, insurance is fully part of finance today, like, if you take it to the broad definition. And so I think the most cases I've seen outside of the price feeds use cases have really been around insurance and weather data, flight data, cargo data. Something else I think we start seeing more and more is actually technical indicators. So people want to be able to automate trading strategies using smart contracts, and they could do it using technical indicators, which are being fed by Oracle nodes. So for instance, ETH RSI, stuff like this. Yeah.
Okay, great. Next question is, what is the current cost per price feed ping on Oracle on Ethereum? Is the service already available on Flow blockchain?
Yes, so it's not already available on Flow. On Ethereum, so we're still kind of formalizing everything on the pricing side of things. Our basic goal is to make it so that we have something fully sustainable, right? So that means that actually network fees should actually pay for the nodes more than network subsidy, right? So that's really is the dilemma. For instance, with Bitcoin, how can Bitcoin sustain itself once it stops printing new BTC, because the fees are not high enough, right? And we don't want to kind of enter a direction where the users are not paying enough to sustain the fees. So right now what's going on is that each user is paying a certain amount on a monthly basis. So we have around 35 users currently paying for price feeds. Now, the pricing really depends on the update rate of the feed and how much time it gets updated a day, right? Because that's where the costs come in. Like you start kind of spending whenever you need to write to storage, right? So whenever you're spending gas and Link to pay the operators and so that they write to storage a new kind of price point. So yeah, we'll be kind of making the exact pricing available soon. But currently, what I can tell you is that every user on the price feeds is paying an amount to make sure that the network fees actually cover the network subsidy and kind of grow larger than network subsidy. Yeah.
Great. I believe those are all of our questions for today. Thank you so much for that presentation. That was fantastic. Just a reminder to everyone that you can follow Chainlink on Twitter at Chainlink, and you can follow Flow at Flow_blockchain. But thank you so much for that presentation and the great answers to all of the Q&A. But yeah, that's it for today. Thank you so much. That was great.
Perfect. Thank you so much for hosting me, and thank you everyone for showing up. Bye-bye. Have a great day.